So when we talk about being able to integrate these rational integrals, a few things that we should consider as a process. And this is kind of keeping in mind that we have partial fractions, we have long division. And so a process to kind of go through is, first of all, if the degree of the numerator is greater than the degree of the denominator, do your long division first. All right. Then that's when you want to go through and do the decomposition. Once you've done the long division and once you've done the decomposition, then you want to integrate everything. And then at the end, there are going to be times where you can use some log rules to simplify. Okay, we're actually going to see that in this particular example. So let's start off with a really basic example that utilizes our partial fractions. So we have x plus 2 over x squared minus 4x minus 5 dx, and we want to try to integrate this. Notice that the degree of the numerator is 1, the degree of the denominator is 2. So we don't even need to worry about that first step. All right, so let's go ahead and decompose this. And let's not even worry about the integration for right now. Let's just focus on the partial or the fraction. And we have x plus 2. And by factoring this, that's going to factor into x minus 5, x plus 1. This is a linear term. This is a linear term. Clearly, they're different. And so I'm going to have a over x minus 5 and b over x plus 1. All right. Now, just like we've done before, we're going to multiply everything through by the common denominator. Okay, so we're going to multiply by x minus 5, x plus 1, and then x minus 5, x plus 1, and then surprisingly, x minus 5 and x plus 1. And when we simplify, those are going to cancel out. We're left with x plus 2. On the right-hand side, x minus 5 cancels. We're left with a, x plus 1. And then finally, the x plus 1 is going to cancel out, and we're left with b, x minus 5. At this point, our goal is to solve for a and b. And this can be done either by picking nice numbers, like -1 or +5, or we can get a system. I'd suggest this system whenever possible. It's a little bit faster than doing all the rote computations. However, if the problem is tedious, such as the one that we looked at in the previous video, then maybe picking nice numbers is going to be the way to go. I'm just going to go ahead and distribute. So we get x plus 2 equals ax plus a plus bx minus 5. And whatever the coefficients of of x are, should be the coefficients of x on the same side. Okay, so notice that we have an x on the left-hand side, which has a coefficient of 1. And so when we make our system out of this, we have that a plus b has the coefficients of x, and on the right-hand side, 1 is the coefficient of x. Right? And then we have a 2, and then our constants, in other words, they don't have, or our zeroth powers of x, if you would, are a and -5b, and that should be equal to 2. Right? And now what we can do is we can just solve the system. I'm going to multiply the first equation by -1. And if I do that, I get -a minus b equals -1. And then we still have a minus 5b equals 2. A's are going to cancel. -6b equals 1. B is -1/6. Now, we know that a plus b should be equal to 1. So -1/6 plus b is equal to, or a, sorry. So we'll go back. So we solve for b. So a plus a -1/6 is 1, which implies that a is going to be 7/6 by adding the 1/6 to both sides. And that tells us now that our integral can be rewritten as the form of these two partial fractions. Okay, so, and just because this is the first time we've done an integration, I'm going to write it out. So the integral, or the original integral, which was x plus 2 over x squared minus 4x minus 5, dx, is now going to be equal to the integral of 7/6, which was a, divided by our x minus 5. and then negative 1/6 divided by x plus 1. So we're just using this as our partial fraction. Okay, so that's going to be negative 6 over x minus 5 plus negative 1/6 over x plus 1, and we have a dx in here, right? Now, later when we do this, what I'm going to do is I'm just going to kind of skip that step and go right to the decomposed interval. In other words, I'm just going to not write that, right? We're going to break it up into two separate integrals, and I'm also going to distribute this or factor out the negative of the 7/6 to negative 1/6. And so now we're going to get 7/6 integral of 1 over x minus 5 dx minus 1/6 the integral of 1 over x plus 1 dx. And as we saw in the very first video, okay, this is just a u substitution of natural logarithms, all right? So again, if it's a linear term and a linear term, then we can just use the natural log of whatever's inside, if it's 1 over whatever it is, as long as it's linear. And so when we integrate, and integration might be the easiest part of this whole problem, 7/6 natural log x minus 5 absolute minus 1/6 natural log of x plus 1 plus c. All right. Now, we could certainly simplify this by using our rules of logarithms. All right. And so what we can do is we can rewrite this as the natural log of the 6th root of x minus 5 to the 7th. All right. So we have that 7/6 power. So we just bring it up there. Minus the natural log of the 6th root of x plus 1 plus c. Then, because we have a subtraction, we could just take the quotient of the two, and we could write like this. So the natural log of the absolute value of the 6th root of x minus 5 to the 7th divided by the 6th root of x plus 1 plus c. And then notice that there's a 6th root that's shared between those two terms. So if you're looking for like the back of the book answer, or maybe the Wolfram Alpha or Symbolab, not saying that this would be the answer from those, but we would just combine that into one big 6th root. We would have x minus 5 to the 7th. In the numerator, we would have x plus 1 in the denominator plus c. All right. Be careful when you're entering your solution into MyMathLab. I'm not sure if they are going to accept this answer, okay, which is a perfectly okay answer to me, okay, but they might want you to go through and do some of that logarithmic simplification. And so just making sure that if they want that, that you understand the process for that. Okay, so rehashing this. First step, we just went through, determined if the degree of the numerator was greater than the degree of the denominator. It wasn't. Then we did the decomposition. Then we integrated, and then we did all the logarithm rules to finish this out. Okay. The rest of the videos in this section, we're just going to do a lot more of these types of problems of increasing rigor.